Hello everyone, and welcome to the next presentation, which is all about solving simultaneous equations. We're going to look at two methods by which you can do that. One of them is the method that you learn at GCSE, which is called elimination, and the second one is the one that we use more in A-level, which is called substitution. Not that you haven't seen substitution before, but it's usually elimination methods that are taught predominantly at GCSE. So let's recap how that works. We've got three examples here. You can write these down in your notebooks if you wish, or you can wait until a bit later on before writing any notes. So in this question, in this first one, you can see that the y's are lined up, the x's are lined up, and the numbers are lined up, which is great. What we also notice are that we have the same number of x's in both equation 1 and equation 2. So there is no manipulation that we need to do with the algebra. All we have to do is to subtract the two equations from each other. Now, you will have also been taught at school that if you have one term like these x's that is positive and one that is negative, you add the two equations together, but that's not what we would do in this question. So if I take these two equations away, I end up with 2y. The x's cancel, leaving me with 12 on the right hand side, which gives me y equals 6. First value found, and then I can take that value of 6 and place it into either of the two equations at the top. So I'm choosing to put it into the bottom of the two equations, and then I would rearrange this equation to give x equals minus 12. Before I move on to the second one, don't forget that you can check that both of those values are right by substituting them into the first equation, just to make sure, and indeed it does work for this example. The other thing I want to say at this stage is that your calculators, your A-level calculators, will solve simultaneous equations for you, but it is important that we know how to do it by hand as well, so hence the reason why we are revisiting at this stage before we start to use calculators. Okay, in this second example, a little bit more awkward because the algebra is not lined up. We haven't got the y's above each other, the x's, the numbers, etc. So the first thing I'm going to do is rearrange them so that they are. So I'm leaving the first equation alone, and I've rearranged the second equation so that, like I said earlier, the algebra is lined up. The other thing I also notice is that I do not have the same number of x's, I do not have the same number of y's. So I'm going to have to do something about that, and to deal with it, I'm going to double the second equation. So I've left the first equation alone. I'm going to double the second equation. Please make sure that you double everything. That's one error that we see a lot, is that students don't manipulate every term inside the equation. So I've doubled everything, and now I can see that I have a positive 2y in equation 1. I have a negative 2y in equation 2, and so, as I said before, because they are different signs, I am going to add the two equations together. And what will happen as a result of that is that the y's will cancel. So adding together, 12 add minus 28 is minus 16, 3x add 10x is 13x, and not straightforward in terms of not an integer answer, but x does turn out to be minus 16 over 13, and at A level, don't be surprised to get awkward fractional values like this. Take that value of x, put it into either of the two equations. I'm choosing the second of the original equations. I've subbed in x is minus 16 over 13, and I end up with y being equally awkward, 7 and 11/13. Of course, you can self-assess and self-mark your work in case you thought that perhaps you'd made a mistake. You can take those two values, put them into the first equation as a check, and again you will find that it works. So we can move on. In number 3, I've got the y's lined up, the x's lined up, the number lined up, the 0 lined up. That's a perfectly acceptable way of presenting them. I'm not going to rearrange them, no need. But the x's are not the same, the y's are not the same, and so I have to do something about that. So there's lots of things we can do, but I am going to multiply the first equation by 5. I'm going to multiply the second equation by 3, and that enables me to get the y coefficient the same. And because they're both positive 15y, I'm going to take the two equations away, and I end up with x minus 2 equals 0. Therefore x equals 2. And similarly, if I put that value back in, I end up with a y value of minus 4. By all means, check within the second equation to make sure that they are correct. So that method is predominantly taught at GCSE to solve simultaneous equations, but there are other methods as well, and methods that we use perhaps more often at A level than GCSE. Okay, good. So this time I've taken the middle example that we just solved using elimination, and I'm going to show you how we can use substitution to solve this pair of simultaneous equations. And of course, we're expecting the same values as we got before. So what we're really showing you here with this example is that in the second equation, we know that y is equal to 5x plus 14. It's very explicit. We know exactly what y is equal to. So there's nothing to stop me now from taking that bit of information and replacing y within my first equation with what I found it to be from the second. So the lines of working that you'll see in here demonstrate that perfectly. So all that's happened is that I've taken my first equation and I've replaced y within it with what I know y is from the second. So y is equal to 5x plus 14. I know that from the second equation. So I go back to the first and I replace y within there with 5x plus 14. And you'll see it's just another way of eliminating the y variable, and what I'm left with is an equation just in terms of x. So I can now work through the algebra, I can expand, I can rearrange, and I can solve, and I find the x value to be exactly the same as I found it in the previous slide. Now at this stage, of course, once you've found the value of x, then you find the value of y in exactly the same way. You substitute the x value that we've just found back into the equation, and that allows us to find the value for y. So same values, just a different way of going about solving. But the beauty of the substitution method is that it works not only for straight line equations, but it works for quadratics, it works for circles, it works for cubics, it works for exponentials, it works for reciprocals, it works for any type of equation that you could get at A level. So unlike elimination, where we predominantly only use that for straight line equations, this method of substitution works for any type, and therefore it's a lot more powerful to use. Good. So to illustrate that it works for any type of equation as opposed to elimination, which only really works for linear simultaneous equations, I've got an example here where we have a quadratic as my first equation and I have a straight line equation for my second, and I'm going to find the solution to these simultaneous equations. Now graphically, what that would mean is, where do these two curves meet on an xy plane? So I've got my quadratic, I've got my straight line. Where would they meet if I was to plot both of those curves? But we'll come on to that a bit later on. So here's my answer. Now again, in the first equation, I am explicitly told that y is equal to x squared plus 10x minus 5. So I am now thinking about, where can I put that information? So I'm going to go to my second equation and I'm going to replace the y within that second equation with x squared plus 10x minus 5. And what I'm doing there is I am eliminating the y variable. Now, if that y variable appears more than once within the second equation, I just replace it as many times as I need to. Now it's time to work through the algebra. So if I simplify and collect together the like terms, I end up with x squared plus 7x plus 10 equals 0. And nicely for us, that quadratic factorizes, and therefore there are two solutions. The straight line is passing through the quadratic twice. That's why we have two solutions. And the first of those solutions is when x is minus 5, and the second is when x is minus 2. But of course that's not the end. I have to find the y value for each of those x values. So if x is minus 2, and I can put this into any of the two equations to find y, it turns out that y is minus 21. And if x is minus 5, it turns out that if I place that minus 5 into the second equation, I get a value for y of minus 30. Good, so over to you. There are two exercises on solving simultaneous equations. At this stage, I would like you to perform these by hand. So just in case you get a show that question in an exam, you can perform the skill without having to use your calculators. By all means, use your calculators for numerical calculations, but not for method. So have a go at these two exercises, ask your teacher if there are any problems, and I will see you for the next presentation. So well done, you've now finished simultaneous equations, and I will speak to you soon. Bye bye.